Good day, folks. Today we are going to look at adding, subtracting, multiplying, and dividing functions. Now we're going to spend 2 days on this unit. The first day we'll be doing as you see, and the second day we'll focus on composition of functions. But for today, let's go ahead and look at how we can perform operations on functions such as what is seen here in the do. In this slide, I want to point out that we can perform operations on functions in much the same way as we perform operations on numbers or expressions. In other words, an individual can add, subtract, multiply, or divide functions by operating on their rules. Well, let's get started and let's show you how we're going to do this. First of all, let's take a look at the operation. So, first of all, I look at addition. This is the notation that we're going to use if I'm adding functions. These are these functions, f, that's the f function, plus the g function. And this here simply means I'm going to take the f function and add it to the g function. Now, subtraction is going to look like this. The f minus g of x simply means I'm going to take the f function, subtract the g function from it. For multiplication, it looks like this, f times g of x, which means I'm going to take the f function and multiply it by the g function. And for division, of course, it looks like this, f over g of x, which is equal to the f of x function divided by the g of x function. Now, there is a restriction that will occur, but we're not going to focus necessarily on that in this lesson. Okay, well, how am I going to do that? Well, in this first example, it says f of x is equal to 4x squared plus 3x minus 1, and g of x is equal to 6x plus a 2. Now, we're going to find f plus g of x. Now, remember, when we find f plus g of x, I would simply take the f function and add it to the g function. Now, what does that mean? Well, we're going to write down the f function in place of f of x. So I'm going to take this function right here, and we're going to put it in place of the f of x, just like that. Okay, the next thing I'm going to do is I'm going to take this g function, and I'm going to substitute the g function right here, and it's going to look just like that. Now, at this point, folks, it's just like we're adding polynomials. You know, this is a quadratic trinomial. This is a linear binomial. How do we do this? Well, what have we been doing? Well, here we're going to get rid of parentheses, then we're going to add like terms. So if I drop parentheses, and we're going to code each of these, make sure you code them, and when you code them, let me see here, we're going to have, let me pick a pen color. Okay, so we have the x squared, we're going to underline with one line. I have the x's, which I'm going to underline with 2, and I have the constants, which I'm going to underline with 3, and then we simply just add like terms, and when we're all done, it's going to look like that right there. And that's all there is to adding functions. When we subtract functions, we're going to do much the same thing. Remember, this is your notation. That simply means I'm going to take the f function minus the g function. So we take the f function and plug it in right there. We take the g function, plug it in right there. Now, what do we do now? Well, remember, I need to get rid of parentheses. I can drop parentheses right here because what's in front of there? Well, really nothing. So what about here? What's in front of there? A negative. So what are we going to do? Well, if you said distribute, that's exactly right. We're going to distribute the negative in there, and then after we distribute the negative in there, then we're going to add like terms. All right, so let's go ahead and show that distribution, and we get that right there. Now at this point, I'm going to underline. We're going to code this. There's my x squared. There's my 3x and my 6x. Those are like terms. Then there's my constants. And we're going to add like terms. And after we add like terms, it's going to look just like that right there. And that's really all there is to subtracting functions. All right, now what about multiplication? Well, first of all, let's review the terminology. F times g of x means we're going to take the f function, times it by the g function. So again, let's take this function, substitute it in for f of x. So it's going to look like that. Then I'm going to take that g function here, this one right here, I'm going to substitute it in for g of x, just like that. Now at this point, we are going to multiply together. Now, just like we multiplied polynomials before, matter of fact, I would probably recommend rearranging this so the binomial was in front of the trinomial. Okay, so in doing so, let's just go ahead and write this up here. So I have 2x minus a 3 times, then I'm going to put my 6x squared minus an x minus a 12. Now, we're going to distribute here. When we distribute, you're going to distribute the 2x times each one of those in the trinomial. Then you're going to distribute the negative 3 into each one of those in the trinomial. And after you do that, it's going to look something like this right here. Okay? There we go. Now, at this point, you're going to add like terms. So, let's underline the x cubes. There's only one of them. What about the x squareds? Well, right there. And the plain old x's, right there. And then, of course, we have our constants. We're going to add like terms. And after you add like terms, it's going to look just like that right there. And that's all there is to multiplying polynomials. So far, we have learned to add, subtract, and multiply functions. And you have found that adding, subtracting, and multiplying functions are just like adding, subtracting, and multiplying polynomials. Well, guess what, folks? We have dividing functions left. And yes, dividing functions are just like what we've been doing with dividing polynomials. Now, there is one thing that's a little bit different. When you divide functions, there are some domain values that may be restricted. Now, we're going to save the restriction part for another unit. So right now, we're just going to divide these functions as if they're polynomials, and we'll concentrate later on the restriction piece. Okay, so here I have two functions here, and we're going to divide them. All right, so remember the notation. You have f of g of x, but that's equal to the f function divided by the g function. So we simply divide these two. Here's my f function divided by the g function. Now, how do we go about that? Well, let's just set it up. So we're going to take the 2x minus the 3, and that's going to divide into the 6x squared minus the x minus 12. Okay, then you're going to ask yourself, what times 2x is 6x squared? Well, it's going to be 3x. You take that 3x times the 2x minus 2x minus 3, and we will get 6x squared minus 9x. At this point, we're going to change the signs and add. This goes out like it always should. It subtracts out. And I'm left here with 8x minus 12. Now we're going to start all over. What times 2x gives you 8x? Well, that's going to be a plus 4. You're going to multiply that 4 times the 2x to get 8x, and the 4 times the negative 3 to get negative 12. And of course, at this point, we're going to change the signs and add again. It goes out. My remainder is 0. So that tells me that the quotient for this is going to simplify to be 3x plus a 4. Now, as we've gone through each of these, I hope you can recognize that when we add, subtract, multiply, or divide functions, we are simply adding, subtracting, multiplying, or dividing polynomials. Well, folks, that's going to give us a wrap for today. Our assignment for next class period is I'm going to give you a handout. So, I guess that's a wrap, and we'll see you in class.